analytical geometry. People, this is about 40 marks. And I want to ask you to be very careful when you do these questions. It's normally 2 questions, so that you can get almost full marks for your analytical. Analytical is easier than geometry, much easier. Make sure you know characteristics of parallelograms and rhombuses and squares and rectangles, because you're going to see them in your analytical geometry. But make sure that you know your distance formula, your midpoint formula, your gradient formula, how to determine an equation of a straight line, how to determine the equation of a circle. Make sure that you know how to determine the angle of inclination, when will points be collinear, all those things that came from grade 10 with you. Those things you must be ready to apply that in your analytical geometry. But those things are not the most difficult things that you've met with during your grade 11 and 12 years. So let's have a look. Analytical. In the diagram below, points 5, P513, Q15, S7,58 is given. SR is parallel to PQ, it's there, where R is the y-intercept, it's on the y-axis of SR. The x-intercept of SR is B, there it is. I'm marking it like that because we're going to need this knowledge when we do the sum. QR is joined. Okay. They didn't mention a parallelogram, nothing else. That is all they gave us there. Now, people, this is not a very difficult sum. I decided to start with it so that you quickly revise all your old knowledge also. Because your old knowledge plus your easier questions will be at least 70% of your paper. And then applications, difficult sums, will be the rest of the paper, where you have to think very hard before you can get a distinction. Right, let's have a look. Calculate the length of PQ. Very, very straightforward, lower grade straightforward. My daughters are doctors, and they will always say this. I said, how sick is that patient of yours? Then they will say, oh, mommy, it's a higher grade problem. But if it's only flu or something, they'll say, no, it was easy to diagnose because it's a standard grade problem that patient has. So people, this is really a standard grade question. Straightforward, but you will get it. Somewhere in your paper there will be a distance formula to be applied. So here it is. There's your formula. I substitute. It's PQ. So it is 1 minus 1 minus 5, 5 minus 13. I made this my second point and this my first point. You can also say the x of Q minus the x of P plus the y of Q minus the y of P. But I prefer the x2 and y2, and then I just decide which one is my first and second point. And this one worked out beautifully because we had those coordinates and it came to a 10. So now we know that PQ is equal to 10. You know, as you go on, fill in the values that you've determined. In analytical and in geometry, it really helps if you can see the things that you have that you can work with now. Okay, question 2. Calculate the gradient of PQ. Again, standard grade problem, because you know the formula for the gradient. y2 minus y1 over x2 minus x1. So now I made that one y2. 5 minus 13 minus 5, and no, I did the same there. It is going to be 5 minus 13, negative 1 minus 5. And that gives me negative 8 over negative 6, which will become positive. And if I want to simplify the gradient, it will be 4 over 3. Straightforward using your formula. Determine the equation of the line RS in the form AX plus BY, please underline that because you're going to forget it. You're going to be so glad that you got the equation in the standard form. You're going to forget to write it in that form. Because normally, when you do the equation, you end up with the standard form. So from there, you write it in that general form because that's what they want. They're going to take a mark if you don't do that. Right, let's have a look. Where is RS? There is RS. I've got a problem. I don't know what the gradient of RS is. And I don't have 2 points on RS. So, I've got something there, but I don't have the real angle there. But they told me that those two lines are parallel. So I take the gradient of PQ and put it equal to the gradient of RS. To define an equation of a straight line, what do I need? The gradient and 1 point at least through which this line runs, so that I can substitute into the equation. So, I can find the gradient. I will say the gradient of RS will be 4 over 3. Why? Because it is parallel to PQ, and there is PQ's gradient. Okay? So now I've got an equation that looks like this. I still need the C value, because my standard equation for the straight line, we all know what it is. Y is mx plus c. I've got the gradient. I need that y-intercept. C is your y-intercept. Okay, but to find c, I need a point on the graph. I need to substitute x and y so that I only have c left. A point on the graph is always x and y. So I can use that point on the graph and I substitute it. I'm going to say y is 8 and x is 7, 5. Calculate that. That times that gives me 10. So I take the 10 to my left-hand side. C is equal to negative 2. Have you got that one? Not very, very difficult. Actually, straightforward. But I know that some learners, after all these years doing equations of the straight line, still struggle to find the equation. I did it by substitution. There's another method that you can use. X1, Y1 minus, I always use this old method. But the other method is Y1 minus Y2 is the gradient X2 minus X1. This is actually the analytical method. And people, it's also very easy, but you must remember that formula. Coming from functions, this is the formula that we used to use there. But remember, you can use this one also. Can you see what I wrote there? I hope so. Okay, people, let's go on. You see, people, what I wanted to do? I was so glad I found a value for C, a value for M. I've got the equation. But what was the question? You must always answer the question. And this is the question. They wanted us to rewrite this equation in that form. So firstly, I'm going to remove the 3. I'm going to multiply everything by 3. The y becomes 3y. The x becomes, if I multiply by 3, 4x, I take it to that side, because look at this. They want it like that. And then 3 times 2 gives me 6. And everything must be on the one side of my equation equal to 0. And there I have it in the form they wanted it. You just remove the fraction. Don't forget to do it. Okay. 3.4. Determine the x-coordinate of B. There's B. They said in the sum that the x-coordinate, this is the x-coordinate of SR. They actually gave it to us. So, people, B is the x-intercept of SR, so we are going to make our y 0. So we take our formula, either this one or that one. It's better to take the one without the fraction. So instead of y, we're going to write a 0. 4x plus 3 times 0 plus 6 is 0. Now I've got one variable, so I can solve for x. And that's all I need to do. 4x plus 3 times 0 plus 6 is 0. So x is going to be, you take the 6 to that side, it becomes a negative, and you take the 4, divide by negative 4, and the negatives will become positives after I've divided them. And that is giving me 1 and a half. You've got that one? I hope so. That is the b-intercept. People, I told you, every single graph has got an x-intercept and a y-intercept. And you must always be aware of it when you do the graphs. If you didn't realize that that is actually the x-intercept of SR, you wouldn't have been able to do this sum. Right, let's go on. 3.5. Calculate the size of ORB. ORB. There's the sketch. There it is. ORB. It's this angle. Kukarosi. ORB. That angle. Let me color in that little triangle. It's that little R in the triangle, not outside the triangle. That one. There. Have you got it? Okay. They want this angle. This one. ORB. Right. ORB is, you cannot determine an angle of inclination for it, can you? No, because the angle of inclination lies on the x-axis. It's always the angle between the line and the positive side of the x-axis. That is inclination. But if I could find that one, I will be able to say that this O1 is also equal to that. Vertical opposite. See how we are using old knowledge? Very important. Then, O there is 90 because it's the y-axis over the x-axis, so that angle is 90. Therefore, the angle at the bottom will also be 90. So, if we can get that one, we can say that it is equal to O1. This one is 90. And then we can say, right, we've got a triangle here. Let's subtract 180 minus O plus B1. Okay, so let's see whether we can get that angle of inclination. B1 is alpha and O1 is 90. I wrote it there. The y-axis is perpendicular on the x-axis and ORB, okay, let's just leave it like that. B1 is alpha. Now I want to find that alpha. So we're going to say the gradient of the line is equal to 4 over 3. The formula to find the angle of inclination will be tan alpha is the gradient of the line, is 4 over. You see, I write step by step. And I hope if you go over this, you will know where I got my answers from. It's very important, people. And tan alpha is 4 over 3. So alpha is 53,13. Second function on your calculator. 4 over 3 second function tan. And that is how you'll get there. But that angle there will also be equal to the vertical opposite angle there. I just want to write the reason in there. Vertical opposite angle. That is why that one and that one is equal. So right, so now I've got those two angles, I can determine the third angle. ORB, ORB, my little angle here at the bottom, is going to be 180 minus 90 minus that one, and that will give me 36,87. And the reason angles of a triangle adds up to 180 degrees. You got it? I hope so. Really not so easy. You can get inclination angles that are much more difficult. But if the angle is not on the x-axis, then you try to find angles of inclination of the lines that goes through the x-axis. And from there, you go to the angle that they actually want you to determine. Good luck, people, with this one. It wasn't a very difficult one. Let's go to the last question there. I actually forgot about the last question. The last question there, prove that QBSP is a parallelogram. I'm going to go back to the sketch just to show you what we've got to prove there. They said prove QBSP, this one, a parallelogram. Now, people, what do you know about the properties of a parallelogram? They've already given us one pair of sides parallel. The property of a parallelogram, both pair of sides should be parallel. So you can work with that, the gradients. You can find the gradient of PS, you can determine the gradient of QB, and if the gradients are equal, it means those two lines will be parallel. Both pairs of lines, opposite lines parallel, therefore this will be a parallelogram. I actually used another property, and I used the following property. I'm going to try and leave the sketch there, and then I'll bring my proof, and I'll show you what I did there. I said to myself, but we've already got those two lines parallel, so if I could prove them equal in length, that will also be a parallelogram. So I determined the length of BS, because I've already determined the length of PQ. It was 10. It was our first question. There it is, there it is, there. Can you see it? So PQ is already 10. So all I had to do was to find the distance of SR, or SB, and if that distance is also 10, it means one pair of opposite sides are parallel and equal, and that will also give me a parallelogram. I also said there, you can use QR parallel to PS, two gradients. And if you've got two gradients of those two, and they are the same, then both pairs of opposite sides will be parallel. Okay, but I did the length one. So I determined the length of BS. And that is, there's your formula, you know that by now. And we've got the coordinates of B and S. So we just substitute it in there. You know by now how to do distance formula. And what did we get? 10 people. It's the same as that one. So QP is BS. QP is BS. And PQ is parallel to BS. Therefore, QPBS, I shall Q that, QBSP, whatever, is a parallelogram, QBSP. One pair of opposite sides are equal and parallel. There it is. QP is BS, they are both 10. PQ is parallel to BS, it was given to us. So QBSP is a parallelogram. One pair opposite sides equal and parallel. I wanted to show you that you don't only have to use the fact that both pairs of sides are parallel. You can also use this one, and you can also use lengths for all the sides. And if the opposite sides are equal, you've got a parallelogram, both pairs of them. Right, that's the end of that question. Let's go to question 4. In question 4, they gave us the following. Look what I wrote there again. You see, people, as I went on when I prepared, I realize that I should repeat a lot of things so that you remember it. Look carefully at what is given. Mark on your sketch as you go on. This is analytical geometry. This is what was given to us. Let's see. In the diagram, E and F respectively are the x and y intercepts of the line having y is 3x plus 8 as a formula. I wrote it there because that's a very important equation that we're going to use a lot. Then, the line through D, for B, I copied this so it's not there. B, 1, 5, making an angle of 45 degrees with our EF line, as shown, has x and y intercepts A and E respectively. A has y, x and y, E and F respectively. That's an x-intercept and that is a y-intercept. Did they give this to us just to give us a difficult sum without we using it? No, no, no. We're going to use all the knowledge from there when we answer our questions. So let's have a look. Question 4.1. There they said, determine the coordinates of E. E is the x-intercept of that line. You see now I've got it right in front of me. So I'm going to say E is the x-intercept of EF. Therefore, I'm going to make y in my equation, y is 3x plus 8. So I'm going to have 0 is 3x plus 8. And therefore, 3x, I take it to that side, it becomes a negative, will be equal to 8. So x will be 8 equal to 8 over negative 3. Right. So there I have my x coordinate. They said determine the coordinates of E. So what's the coordinate of y there? 0. Because the equation of my x-axis is always y is 0. The equation of my y-axis is always x is 0. Right, so please remember that. So the coordinates of E, that's your x coordinate, and that is your y coordinate. There it is. Done with question 4.1. Let's have a look at 4.2. Calculate the size of DAE. Ah, there's DAE, this one. There it is. People, the moment they want the size of an angle in analytical geometry, you work with the angle of inclination. Tan of the angle is equal to the gradient of the line. Tan of the angle is equal to the gradient of the line. But now I've got a problem. I do not have the equation of that line. I do not have the gradient. I only have 1 point. So how on earth am I going to get the gradient of that line? Now I wrote it here. First calculate FEO. It's the only way that we'll be able to do this. You'll have to calculate that angle of inclination. If you've got that angle of inclination, you know that those two are vertical opposite, you will be able to find A. Without angle of inclination, you will find A by using the exterior angle of that little triangle. Well, people, what did I say to you? The exterior angle of a triangle is equal to the opposite two interior angles. Will somehow be in your every single paper that you use. So watch out for it. Watch out for it all the time. Right. I'm going to determine this angle here, because I've got the gradient of that line. then I'm going to say the tan of FEO will be equal to the gradient of the line. Can you see that? So now you say 3-second function tan, and you will get 71,57. 71,57. Have you got that one? All right. Now I've got that one. I can say ADE, or DAE I wrote there. Same thing. Is 180 minus, oh, I went and I did that one also, but it wasn't really necessary, but you can do it. Another method. I actually determined a DEA. DEA. And I said, okay, I said ADE is 45, vertical opposite. Then I said DAE. No, it's DEA. I made a mistake there. DEA will be 180 minus 71,57, and that will give me 108. People, I think I did this because I wanted to show you that you must also be aware of angles on a straight line. It's always 180 minus the other angle. I've got a candidate that I'm teaching in grade 11 at the moment, and he doesn't see that. He sits there and he said, I don't know how to find that angle. Because he thought, it's old knowledge, I'm going to forget the knowledge that I got in grade 7 and 8 and 9. But this is very important that you realize that you can even use a straight line in grade 12. So I got that angle, and then I worked with angles of a triangle. I said DAE is 180 minus my 108 minus my 45. And that is giving me 26,57. Oh, there I wrote it. Or you can use the exterior angle of a triangle, which is actually a little bit easier. You don't have to do this. You can immediately say FEO will be equal to D plus A. And D is 45. So you just subtract 45 from there, and you're going to get exactly the same answer. Okay. You can use both those methods. Okay. Let's go on to 4.3. They said determine the equation of AB in the form y is mx plus c. Now they want the equation of AB, and they want it in standard form. Now we've got a problem because we still don't have the coordinates of A. We do have the coordinates of B there, but we want the gradient. So what are we going to do to find the gradient? We know now what the size of A is. So we can determine the gradient by using the angle of inclination, backwards. So we're going to say, we have DAE. We can determine the gradient of AB, and we're going to use angle of inclination. We're going to use inclination. The tan of the angle will be equal to the gradient of the line. There it is. The tan of that angle that we got for DAE will be equal to the gradient of AB. And the gradient of AB, what was that? Let's have a look. The gradient of AB, we don't have it, so we'll have to find it. That's why we are using this formula, people. The tan of 26,57 is 0,5. Using your calculator for that. Straightforward. The tan of 26,57 is the gradient of AB. And now we've got an equation thus far. We don't have C. But luckily, let's go to the sketch again. We have a point on that line, 1 and 5. So we can substitute the point into this equation. 1 is x and 5 is y. And in the end we get 4, 5 is equal to C. So the equation will be half y is a half x plus 4 and a half. There it is. That's the equation of AB. Let's quickly do the other method also, the analytical method. Y2 minus y1. I want to show you something here. People, do you have two coordinates on that line? No, we don't. We only have B. We only have B. So we won't be able to use that method. This is the method that you're supposed to use in this case. Okay? Right, people? Another one. Now, is there another question on this page? Let's quickly check it. Calculate the, there's another question, and a wonderful question. I know why I did this. I wanted to get to the more difficult questions, right? Okay, let's see. The next question is, if AB has an equation of x minus 2y plus 9 is 0, determine the coordinates of D. Wow, okay. You know, they made it very easy for us. We have just determined the equation of AB, but we determined it in the form, let's take the other page, sorry, I just wanted to put it there. We've got the equation of our dear AB in this form. We just did it in question 4.3. And now they say, if AB has an equation, so what did they do? They gave us the equation that we determined just in another form, in a general form. So we can take that equation and just check whether our equation is the correct equation. Okay, let's see. I took that one. But let's quickly see whether we can rewrite this in that form and whether we're going to get the same thing. We are going to multiply by 2. So 2 times y is 2y. If I multiply this by 2, I'm going to get x. If I multiply 9 over 2 by 2, we're going to get 9 plus 9. Let's go back there. If I take the 2y to this side, we're going to have exactly what they gave us. X minus 2y plus 9. I realized that, so I actually took the one that we got, but you should take that one, because that is certainly the correct answer. Say, for instance, that one was wrong. Then you use the one that they give you, because you know that that one should be right. Okay? Now let's have a look. To get that point D, let's go quickly back to the graph there. We are going to determine the point where the two graphs intersect. And if two graphs intersect at the same point, they will be equal in that point. Okay, I know now why I did this. Because people, you cannot put the graphs equal to one another unless they are in standard form. So what I did here, I just checked myself and I saw my equation is right. So I'm going to use that one. It is in standard form. Can you see that? Y is, and the other one is already in standard form. They gave it to us. Y is 3x plus 8. So we're going to take those equations and just put them equal to one another. Half x plus 4.5 is 3x plus 8. We want to solve for x in this case. It's actually a simultaneous equation. You could have numbered that one number 1, this one number 2, substitute the one into the other, and it will bring you where we are now. Because of this, in analytical geometry, we normally put the two equations equal to one another, unless the equations are very difficult. And then you can name it 1 and 2 and do a simultaneous equation. Remember, people, a simultaneous equation means solve for x and y. It is also the point where those two graphs intersect one another, where they are equal. That's all of that is exactly the same thing. So there I've got negative 2.5x. Look at this. I subtract a half from 2.5. Yeah, from 3. I skipped that step and I didn't want to do it. I'm going to rewrite another step here. Therefore, a half x minus 3x is equal to 8 minus 4.5. From there, you go there. A half x minus 3x gives me 2.5, but it's a negative because 3 is the bigger number. And then 8 minus 4.5 gives me 3.5. And there I have it. And when I take my calculator, I divide 3.5 by negative 2.5, I will get negative 1 and 5 over 2. Let's look at it again. I want to solve for x. So I took the x's to the one side, I took the numbers to the right-hand side. I added the x's, it gave me negative 2.5. I took 8 minus 4.5, and that gave me 3.5. Then, because I want x, I divided by the 2.5 on both sides, and I got 1,4. That's where I got this. It's 1,4. It's 2,5 divided into 3,5. It gave me 1,4. And 1,4 is 1 and 4 over 10. So it's 1 and 2 over 5. Have you got that? Fractions, fractions, fractions. But you are supposed to be very good on your calculators. You can use the fractions actually there also. You don't have to make them decimal fractions. Okay, subject. But now what did they ask? They say they want the coordinates of D. So by now we only have the x. And the x is negative 1 and 2 over 5. So how do I find the y? Oh, people, it's like you did in calculus, like you did everywhere in your previous work. If I've got the x value of a point where two graphs intersect, or if the point is just on the graph, I can just substitute that x value into the equation to get the y value. Now, the equation is actually that one, people, or that one. They gave us that one. It's going to be much easier to substitute it in there. In any one of the equations, you can substitute. So you can substitute in there also. Any of the two equations. Substitute for y core in any equation. And I decided, I don't want fractions. So I took the one that they gave me, which is actually exactly that one. And I substituted the x in there. And then I put, instead of x, I put 1 and 2 over 5 minus 2y plus 9 is 0. And then I left the 9 here and I took the 2y there. So, because I wanted to make the 2y positive. And then I divided the answer that I got there by 2. And then I got my y equal to 3,8, which is 3 and 4 over 5. People, you can leave it in decimal form if you want to. But if you write the coordinates, if the one is a fraction, the other one must also be a fraction. So this could also be negative 1,4 and 3,8. And you would get all your marks. Have you got it? Very nice question. There's another question. The level 4 question for this sum. And the question there, let's have a look at it. 4.5. 4.5. Now I'm going to do 4.5. I'm going to fold this one and put it there so that I don't confuse you with the previous sum. Okay. 4.5 read like this. It said, calculate the area of quadrilateral DMOE. Let's go and have a look at the sketch first. Where's that quadrilateral? There it is. DMOE. It is this one. Now, people, if you look at that, how do you determine the area of a quadrilateral that is not even a rectangle or a parallelogram or whatever? It is a quadrilateral and all the sides are different. So there's no formula for that. So you'll have to make another plan. Let's go down. Can you see that if we could find the area of that triangle minus the area of that one, we will have the area of DEOM. Can you all see that? But how? To find the area of FEO, I need this length, it's the base, and I need the height. Now let's see whether we don't have it. Because we have the coordinates of E. We have. There it is. So this length is 2 and 2 over 3. It's negative because it's on this side of the axis. Then the length of FO. Do we have the coordinates of F? We didn't do it, but we've got the equation of that straight line. So F is going to be the y-intercept. So those coordinates will be 8 for y and 0 for x. Do we have the coordinates of M? Let's have a look. M. No. M is the y-intercept of this line. So, in order to get these coordinates, we will have to get M's coordinates. We've got the equation. We know that this is the y-intercept. So let's go and check for that one. The y-intercept of that one, the equation there, is actually, this is difficult because they are done on different pages. Let's see whether we can see the y-intercept of this graph. This one. We've got that one. There it is. Because this is the equation of AB. This is the equation of AB. See that one? So that 4.5 will be the coordinates of M. 0, 4 and a half, or 4.5. I did this because I need it. I said to you, what we're going to do, we're going to find the area of that big triangle minus the area of the small one. And we will be able to do that. This one is not a rectangular triangle. But now you must think, how do you find the area if you have this length, and the angle in between? Trigonometry, people. Trigonometry. The area is a half AB sine 45. So it will be a half FD times MO and the sine of 45. But do we have DF? No. Do we have MB? No. But we can determine it because we've got all the coordinates of these points. What is the coordinate of D? There it is right at the bottom. I'm going to write it there. You don't see it. -1 and 2 over 5, 3 and 4 over 5. There they are. So we've got coordinates. We can determine the length of that the length of that. If you've got two sides, included angle, we can use our trigonometry formula for that. Half df times dm, the sine of 45. That will give me the area of that small little triangle up there. Right, people? I'm going to do it now. You won't see the sketch because the sketch is too far away from the sum that I did. So let's go and have a look at this sum. Maybe I can put it there. And then you will be able to see the sketch while I'm doing the sum. Okay. 4.5. They said determine the area of DEON. We decided that we're going to do the area of the big one minus the area of that. The area of that we can only do by using trigonometry. The area of this big one is very easy because it's perpendicular there. So this is half base times height. And you've got the height. The height is always the y value. M is the y-intercept of AB. You see, we'll have to find all of that first. And that will be 4.5 because we've got the equation. That one. Then we've got F because F is the y-intercept of that equation. There I've got those two pairs of coordinates. We've also got D. We just got D because we determined D by putting the two equations equal. Okay, people. Now, we'll have to calculate the area of FEO minus the area of FDM. But before that, we'll first have to find the length of DF and DM. So DM is DM, there it is. You've got the coordinates. You use them. 0 minus that one. 4.5 minus that one. And in the end, I got this length of DM 1,45. It's impossible. The square root of 245, I think something fell out here. It should be, let me see, I think I've got it somewhere. That's the length. 8/3, because why did I write that there? Just leave it there. I'll go back there just now. Then DF, we've got the coordinates. We substitute it into our distance formula, and DF is 4,427. Then the area of DMOE, area of the bigger triangle minus the area of the smaller triangle. There it is. The area of FEO will be the area of DMOE, will be the area of the bigger triangle minus the area of the smaller triangle. Now the area of the bigger triangle is half base times height. Half base times height. Now this is 1,57. I'm quite right there. But I don't know why. Oh, this should be 2,45. That's what I didn't write. There. Right, people. Half base times height. Half. Now look at the big triangle. Let's go back there. This is the base, and 8 is the height. So let's go back to our sum. Half. 2 and 2/3 is the base. So it is 2 2/3, exactly what we got, times the height, which is 8, minus, now the area of that small triangle is half. I just want to write the formula for you there also, so that when you practice, you should see what I've done. FD, or DF, times DM, and the sine of 45. 45. Right. I wrote it there because if you want to go back, you will know exactly where I got that from. Okay? So, we determine that area. we determine this. It's one calculation. You press half or 0.5 times 4.43 times 1.57 times the sine of 45. You do it in one shot. And then this is what you will get. Then you subtract those two, and this will give you the area of DMOE. Beautiful question. Definitely a level 4 question, people. But try to remember what we did. You see, in each one of these sums, there's something else that we're doing to get to our final conclusion. And that is what makes it difficult. But if you practice all these different kinds of things, you will recognize it in the exam. People, maths means practice, practice, practice. Practice, practice, practice. That's why you must have a book, and in that book, you do the sums. You don't only look at the sums. Can you see how I prepared? I did all of these sums. I did them. And I went through them again so that I can be sure of the explanation of each of these sums. So you must also do it. You can't just look at mathematics. It's of no use. You can cheat your mother. Go to your room and look at your mathematics books for 3 hours. And tomorrow when you write the exams, you will not do well. Then mommy will say, but he did mathematics last night for 3 whole hours. But what mommy doesn't know, you didn't even take out your pen to do the sums. And you must even practice the easy ones. That's why I did the easy ones with you. Because don't think you will remember everything if you didn't do it at least once before you wrote exams. You know, people, they say, if you don't do math for a week, your knowledge is behind with 2 weeks. So if you don't do math for 2 weeks, your knowledge is behind with 4 weeks. And that is the truth. Both my daughters are doctors. And they said to me long ago, after they did their doctor's degree, they said to me, you know what, Mommy? If you give me grade 8 mathematics, I'm not going to be able to do it. But because for 7, 8 years, I didn't touch mathematics. Because when you study for a doctor, you don't touch mathematics. You must have it, but you don't do mathematics in your course. They say they don't remember a thing from mathematics high school, and both of them got distinctions. So if you don't do math, you can't do it after a long time. So please, people, mathematics, work, work, work. Practice, practice, practice. Let's go on to our next sum for analytical. And now we are going to be doing circles. Grade 12 work. Okay, let's see what they gave us there. They gave us, in the diagram, the circle centered at M24, so it's a midpoint, passes through C, -1, 2, there it is, and cuts the y-axis at E. So that is your y-intercept of your circle. There's another one. Can you see it? Don't forget. The diameter of CMD is drawn, and ACB is a tangent to the circle. So that's a diameter, that's a tangent. What do you know about a diameter or a radius on a tangent? Yes, people. It is perpendicular. You see how I'm bringing in my geometry knowledge? Very, very important. That's why if you know that geometry things that you must check when you do a circle sum, you will recognize it in all the other sums that you do. You must know it off by heart. It must be part of you. So when you look at the circle and you see a tangent, you will say, oh, that is 90 degrees because I know it. So please, go and learn those things off by heart. 4.1.1. Determine the equation of the circle in the form x minus a plus y minus b is r squared. Now people, this is the one question that they can ask about circles. The other one is where they ask you to find the midpoint and the radius. Those are the two questions about circles, and then apply other knowledge for other questions also. Right, let's have a look. The standard form of a circle looks like that. The circle is, no, this is actually a general form. The standard form will look different because standard means y is. But this is the form of the circle is equation that we are supposed to use. This one, not the standard form. Right. So let's look. This one, A and B, is always your midpoint. The x and the y is always a point on the graph. From here to there, you have the radius. So we are actually working with the distance formula. We didn't put in the square root because there we wrote radius square. But if we want to find the radius, we will have to find the square root of this. But we normally find this first, and then right at the end we determine the square root to find the radius. But in the formula you've got radius square. Now let's have a look. If we can substitute the x and the y and the x a and the b, we will be able to find the radius square. Think about the parabola. There you had to find a. Then you put it back into this equation. So let's see. Here we have to find r squared, and we're going to put it back in. We don't want r, we want r squared. So we don't put the square roots there. Right. This is the equation that you learn off by heart. You make sure that you know where to start when you must find the equation of the circle. That is where you start. Right. Now we substitute. Into x, we substitute -1. X minus a. Oh, look what I did. I swapped these around, and I didn't have to do it like that. But it will give you the same answer in the end. Let's rewrite that one quickly. X minus a. X minus a is going to give you -1 minus 2. Plus, then y minus b. Y minus b. And that gives you r squared. Remember, people, when you do the distance formula, it doesn't matter at which point you start. If you say this is your y2 and x2 and y2, then this one will be your x1 and y1. If you say this is your second coordinate, then that one will be your first one. Oh, I'm explaining with my hands, but I don't think you can see me, né? All the time. Okay. So it doesn't really matter whether you start with this going there or with this one going there. It's a distance formula. And whether you add or subtract, it will give you the same there. Look at this. This is 3 squared. This is -3 squared. It will give you the same answer. This is 2 squared, and this is -2 squared. Same answer if you square it. So it's 9 plus 4. That is your radius square. And there you have your radius square. Now people, they want the equation. Like in the parabola, I determined the r square. So I'm going to put it into my equation. They don't want a and b in the equation. They only want an x and a y in the equation. Why? Because every single graph has an x and a y in their equations. So now I'll go back. And I put back those two, the midpoint and the radius square. And this, people, is the equation of this specific circle. There it is. So you had to find A, B, and R. A and B is easy because you just look at the midpoint. But the r you've got to calculate by using the distance formula. You got that? I hope so. It's actually a straightforward question. But the thing is, you get confused when you must write the equation. And it's in that form. The a and b shouldn't be there. In any equation, there shouldn't be an a and a b and a c and d, only x and y. It's exactly like you do the parabola. Determine a, put the x and the y back into the equation, the final equation, and only put the x-intercepts in there. Okay, let's have a look. 4.1.2. They said, write down the coordinates of D. There. Can you see that M is the midpoint of the diameter? Because it's the midpoint or the center of the circle. So, to find D, we will have to say D is x, y. And we will have to work with the midpoint formula. So glad the midpoint formula jumped up in this question. M is 2, 4 is the midpoint of the circle. Negative 1 and 2 is on the circle. D, x, y, we're going to use the midpoint formula because D, x, y, is also on the circle. Remember that. Okay. So, I'm going to separate the x-intercept. I'm going to use the x-intercept separately and the y-intercept of, or not intercept, the y-coordinate of the midpoint and the x-coordinate of the midpoint. Because I want to solve x and y. So I'll have to separate my midpoint formula. So let's have a look. To find the midpoint x-coordinate, I use this formula. You remember? Normally we put it together when we find the midpoint, né? But I want to do it separately because I want to solve x. I want to solve the x there as well as the y. Okay, now go back. We've got the midpoint x, it's 2. We don't have x2. Let's make that now. x2 and y2. We don't have it. So we're going to say, but we do have this x and y. So we can say x2, this x is negative 1. That formula has got a positive. It's not like the distance formula. Plus negative 1 divided by 2. So can you see we've only got that variable there? So we can solve it. So we're going to do cross multiplication. 2 times 2 is 4. x2 minus x1. And x1 is actually negative 1. So I'm going to put the x2 or the x of D, that's the point there, is equal to 4. And you take the 1 to that side, it is 5. People, the moment you've got to find x and y, using the midpoint, you've got to separate those two formula. Now, we also have the y coordinate of the midpoint, which is 4. We don't have y2, but we have that y. So it's y2 plus 2 divided by 2. So we want to find that value. So we're going to say y2 plus 2 is 4 times 2. Cross multiplication. So y2, which is actually the y of the D coordinate, that one is going to be 8 minus 2, which will be 6. So the coordinates of D will be 5 and 6. I wrote it there. That was the question. You always make sure that you end up with what they want from you. Don't just stop there. Write the coordinates because they said find the coordinates of D. I know those are, but if you write it in coordinate form, this is the coordinate form. Minus 1 if you don't do that. Please, people, read your questions very, very, very well. Right. That was 4.1.2. Now 4.1.3. I should bring my sketch back so that you can follow me on the sketch. Let's put it a little bit up there so that we have enough space here to do 3 more questions. Can you see there's 3 more questions there? 4.1.3 is the first one. Okay, let's have a look. 4.1.3, this is what they asked us to determine. They said, determine the equation of AB in the form y is mx plus c. Now people, I hope if I close it here, you are quickly going to think how you are going to find the equation of the tangent. Oh, very important for calculus also. What are you going to do? You only have 1 point on that line. But you know that this line is perpendicular on that line. So, the gradient will be the opposite of this one. This gradient, you take the opposite with the opposite sign of this one, or then you'll find the gradient. To find an equation of a straight line, I need m and c. There's no other way to find m because I only have 1 point. So I'm going to determine the gradient of CD, m to 4. Sorry, I'm at the wrong one here. Let's go to 4.1.3. There it is. Okay, let's just write that 3 there. Okay, question is, determine the equation of AB, equation of the tangent. So I'm going to find the equation of the radius there, or the diameter. I'm going to say the m of CM. Now there's your m, CM. I could have used CD also. But say, for instance, my coordinates there are wrong. Then my gradient is going to be wrong. Those were given. So I'd rather use the given coordinates. It's also on that line, okay? The m of CM is y2 minus y1. You know that now. It is 4 minus 2. 2 minus 1. That gives you 2 over 2 plus 1, which will be 3. So that is the gradient. Okay, I've just said this to you. The gradient of CM is 2 over 3. We calculated it by using the gradient formula. Then the gradient of the AB line will be the opposite of that one. You swap the x and the y and you put the opposite sign. So y is negative 3 over 2x plus c. This is the equation of A, B so far. We need C still. So what are we going to do? We are going to substitute that little point into the equation. You can only use this method because we do not have 2 points. Right, people? Then you substitute negative 1 and 2. Why do we substitute negative 1 and 2? Let's go back quickly. Because that point is on the line. You must substitute a point that is on the graph. So that is why we are substituting negative 1 and 2. This is x and this is y. So instead of x we write the negative 1. Instead of y we write 2 plus c, because we want to solve c. So we're keeping the c on this side and we're taking that negative times negative 1.5, 3 over 2. It's a positive 3 over 2. We take it to that side. It becomes a negative 3 over 2. And 2 minus 1.5 gives me a half. So c is equal to a half. I just want to write this like this. C is 2 minus 3 over 2. So C is equal to a half. That's where I got it from, okay? So the final equation, if you stop there, you're going to lose a mark. They said, find the equation in the form y is mx plus c. So now I write the equation y is mx plus c, which is a half. I hope by now you can do a straight line, because we've done quite a lot now. It's not difficult if you understand it. So that question was really not a difficult question. Then we will have the only difficulty there, for that I just mentioned, saw it there now, was the fact that you should realize that that is 90 degrees and that you determine the gradient of that, and then from there determine the gradient of AB. Right, people? 4.1.5. 4.4. They said, calculate the coordinates of E. Now, where's E? Let's go down, let's go down. There's our E. And what is E? It is the y-intercept of our circle. Have you got the equation of the circle? Yes, you do. You are going to say E is 0, y. X is 0 for the y-intercept. Calculate y-intercept of circle, make x 0. Right, we're going to go on there. The y, there's your circle's formula. The circle's formula was x minus 2, y minus 4 is equal to 13. But instead of the x, I'm going to put zeros, because I'm substituting the point on the circle. I'm not substituting the midpoint. That is the midpoint there. X is 0, x. X is 0 there also. And then I've got negative 2 squared, which will be 4. And there I will have x minus 4 times x minus 4. Long multiplication. It is, this one is, no, but the x became 0. Sorry, people. So it's only x. Oh, I see what I did there. I actually multiplied my original circle, which was really not necessary. I can say negative 2 squared is 4. And negative 4 squared is 16. And 4, and that y squared minus 8y. Where did I get that from? Let's quickly see. X is 0. No, this is what. People, maybe I must just go and rest for a while. Y minus 4 stays there. I only made the x 0. So I did it correctly, but now I'm a little bit asleep, like some of you. I think some of you are also feeling like that. Okay, y minus 4 gives me y squared minus 8y plus 16. And that's where I got that from. Can you see? This is 4. And that is equal to minus 13, because that is the original equation of my circle. Right. So now I can bring the 13 to this side to put it equal to 0, because if I look at this, I'll see that this is a quadratic equation. And a quadratic equation must always be written in standard form, equal to 0. Right. Y squared minus 8y plus 7. I brought the 13 here, and it gave me 7. 4 minus 13 is minus 7 plus 16 gives me 4 minus 13 is 9. Minus 16, it's negative 9 plus 16, it will give me 7. That is right. Right. Then I factorize that. Y minus 7, y minus 1 is equal to 0. Check whether you're right. -7, -1 gives me -8. You can always check your trinomial. Multiply the 2 on the inside, multiply the 2 on the outside. That should give you your middle term. Okay, right. So the coordinates of E, let's have a look on the sketch again. We got two values for y. Y is 1 or 7. Can we have a look? Ah, there's another y-intercept of our circle. This will be the small one, and that one will be the bigger one. So E will be the 7. So the coordinates of E will be 0 and 7. Not so difficult. Not so difficult. You merely substitute the point into the circle's equation. And don't do what I did. This is not 0. It is y. Sorry for that. But maybe it's a good thing now you will also remember not to make that mistake. Let's go to 4.1.5. I'm just going to read the question to you. Show that EM is parallel to AB. Now let's go to the sketch quickly. EM will be there. And there's AB. I've already got the equation of that, so I do have the gradient of this line. That will be exactly the same as the gradient of EM. Why? Because they are parallel, people. So, if I've got the gradient there, I can actually say it will be the gradient of that also. But if you didn't realize that, you could have determined the gradient of that. Because you have E now, E is 0, 8. And you've got that point, so you can determine the gradient by using the gradient formula. But it's so easy if you remember the two lines are parallel. Beautiful. So I've got the gradient already, and I've got this point and that point. But I will use this point, because this point was given to us. So I'm sure that it is correct. So let's go to 4.1.5 quickly. 4.1.5. The gradient of AB is -3/2. There it is. Let me just show you. We calculated the equation. So we've got the gradient of AB, and that gradient will be exactly the gradient of EM. Exactly the gradient of EM. Writing it there so that you can see where I got it from. Oh, then I determined the gradient of EM. But you can, okay, I'll write the next method there. It's going to be 4 minus 7, because that's E. And 4 is your midpoint, minus 7. Midpoint 2 minus this 0. So I used the gradient formula. Now, I can see the two gradients are equal, therefore they are parallel. Oh, I see. They didn't want the equation of EM. They just wanted us to prove that they are parallel. You see how we can read wrongly? I wanted to find the equation of EM. You wouldn't believe me. Okay, they just wanted us to prove that these two are parallel. So the only way that you can do it, determine the gradient of EM. But the gradient of EM is equal to the gradient of AB, therefore they will be parallel. Ooh, this was quite a nice little sum, people. So make sure you can do it. Not so very difficult, but not very, very easy. Make sure you can do a sum like this. Okay, now we're going to go to our last sum for analytical geometry. Right, let's see what we have here. Here we have a question 12. and the sketch is not underneath the question, so I'm going to have to show you that, like that, so that we can first read our question. In the diagram below, P and Q are the centers of these two circles. And the circles have equations. X minus 7, y plus 2 is 49. And then that one was given in the general form. Can you see that? They actually removed the brackets here. I'm very glad that we have a question like this also. They said, determine the radius of the circle with center Q, the bigger one. Oh, now you'll have to say, oh, cooks, I know the radius of this circle is 7, because this is r squared, but is it the circle Q? Let's have a look. Plus 7 for x and negative 2 for y. That will be the midpoint of that circle. Positive 7 for x and negative 2 for y. Oh, it is P's coordinates that. And they actually gave it like that. They say P and Q. P and Q. They normally give it to you in the correct order. But I wanted you to check it. If they didn't say that, how will I know which equation fits which circle? This equation fits circle P, so that equation will fit circle Q. And then what do they want? They say determine the radius of circle Q. You've got the radius of circle P. This is radius squared, so the radius is 7. But you don't have that. And people, this is a very regular question. I told you when we started, there's two types of circles. The one where they give you in this form. Then this will be the midpoint, plus 7 and negative 2. This will be the radius squared. But this is given in a different way. So you will have to use completion of the square twice to get this circle into that form. Now let's have a look. We use this equation, do completion of the square. Now let's have a look to find the midpoint and the radius. Now let's go and look how we are going to do it. I wrote down the equation x squared. I put the x next to the x there. Then I left this out at first. There was a space there. Then I wrote the y's, y squared minus 6y, and then it's equal to 30. Then I said, right, what are we going to do now? Completing the square. I should have left that spaces there. Okay. I left a space there and a space there because I'm going to complete this square and I'm going to complete this square. How do you complete a square? Let's close that. You take the half of b and you square it. Half of 10 is 5 and then you square it. Let's go to the y side. Half of 6 is 3 and you square it. But now I disturbed my equation. This side is much heavier than this side. So what must I do now? I must subtract I added here, so I'm going to add on that side. Because this side is now looking like, oh, you won't see me. I'm explaining with my arms and you won't see me. This 25 and 9 was added to the left-hand side. So the scale is now hanging over to the left-hand side. So I must do the same on the right-hand side. In an equation, if you touch something on the left-hand side, you do exactly the same on the right-hand side. So I'm going to add 25 there, and I'm going to add 9. I didn't have space there. Then I factorize this trinomial. It's going to give me x plus 5 square. It's a perfect square. What do we do when we complete the square? We make a perfect square. So the two brackets should be exactly the same. Positive there, so it's both is going to be positive, two brackets. Then we go to the y. We factorize that one. Y, the signs will be negative 3 squared. And then we add all of those, it gives me 64. So people, what will the radius of circle Q be? 8. The square root of 64. Have you got it? That's the radius square. Don't forget that. I wrote it there so that you will remember it. The square root of that is 8. So the length of the radius of the largest circle is 8. What is the length of the radius of the smallest circle? 7. Can you see? There we have that one. Because it was already written in the form that we should have our circle. Right. B. What did they ask there? Calculate the length of PQ. PQ. They are overlapping there. Can you see? So we'll have to find a way to do it. But what we did previously, we're going to use now. If you look at circle P, the midpoint is 7 and negative 2. If you look at circle Q, we wrote that circle in this form. So the midpoint of Q is going to be negative 5 and positive 3. See how you use your previous calculations. Always look at your previous calculations. See whether you can get a plan to do the new question. Right. Now they said determine the length of PQ. Oh, people, you can all do the distance formula. So I'm not going to bother much there. PQ, there I wrote the coordinates in front of me so that I know exactly what to subtract from what. 7 minus 5, minus 2 minus 3. And in the end, I got a lovely answer, 13. So PQ is equal to 13. You can write units there if you want to, but they didn't mention units in here. So it's fine, fine, fine. Right. Let me write units just for the sake of love. Okay. Question C. Show that the equation of PQ is this. Oh, people, that's really easy because you've got 2 points on that line. So you're going to determine the gradient. There's the gradient. Then you're going to determine, or you're going to substitute one of those points into the equation, and your equation will look like that. If you're not sure about this, you can go back and check on it. But there I explained how I got to that 2 and 11 over 12. Or how I got that. 5 over 7 times 7 is 35 over 12. And that is this one. I took it to that side, and I subtracted it from 2, and that is, or I added it to 2, and that is what I got there. So I skipped that step because I thought to myself, wow, if you can't do this question, you cannot get a distinction in mathematics. That is impossible. That was question C. Now we're going to do question D. Very short and easy. Determine the coordinates of A. There's A. What do we have to do? It's the point where these two graphs intersect one another, the straight line and the circle. We've got the equation of the circle, there it is. We've got the equation of the straight line, there it is. So all you need to do is to substitute the y in your circle's equation there by negative 5 over 12x plus 11 over 12. Only the y must be substituted. So y is, no. Oh, sorry. This is C still. You see, I'm so glad I did this. I got the equation, but I never wrote it in this form. Can you see that? Underline that, and please remember, you must write that in that form. So I multiplied by 12 right through, and this is what I got. when I wrote it in that form. Voila! Beautiful, beautiful, beautiful. Then D is determine the coordinates of A. A, the point where the two graphs intersect. So I'm bringing my D in now, and we're going to do the D quickly. We know that the equations of the two graphs. A point where two graphs intersect, QP and smaller circle. That is what we are going to determine now. The point where these two graphs intersect, QP, the straight line, and the circle. Right. I rewrote the straight line here. There it is. If you want to find the point of intersection, you need to find X and Y. Now in this case, we must use the standard form of the straight line, make it Y, so that we can substitute that number 1 into number 2. There's the circle equation. So where we have a Y, we're going to put that in. It's a little bit of calculations that we're going to do. We're going to have x minus 7 squared. Instead of y, we're going to write that plus 2. Everything squared is 49. Then I'm going to add those two. It's going to give me 2 and 11 over 12. And then I'm going to multiply that one, x minus 7 times x minus 7. It will give me x squared minus 14x plus 49. When I get the square of this, it's actually going to be the square of, let me write it here for you. It's going to be the square of negative 5 over 12x plus 2 and 11 over 12, because I added those two. And that must be squared. Now this is going to take quite a few minutes because it's fractions and you can't remove those fractions. You cannot remove them. It's part of a whole sum there. X, and let's make that 2 times 12 is 24 plus 11 is 35 over 12 squared. So you're going to square that. It's going to be, there it is, 25 over 144 x squared. It's the first brackets, the first terms that I multiplied. Then I'm going to multiply this one by this one, and then I'm going to multiply it by 2 to get that term. So it's negative 5 over 12x times 35 over 12 times 2 for the middle term. For the last term, it's going to be that one squared plus 35 times 35 gives me 1225 over 12 times 12, 144. Now this one will give me, you can still see what I'm doing, this one will give me 350x over 144. So now we can go back to what I did there, because I explained how I got to that answer already. So that is what we got there. Then we've got a 49 there, which I brought over, so the two 49s will cancel one another. Then I must times by 144 right through the equation. That is 144 times x squared. 144 times that gives me that. The 49s are out. Then if I multiply this one by 144, there's only 25x squared left. If I times this one by 144, I've got 50x. If I times that one by 144, I've got 1225 equals to 0. People, this is quite a difficult. It's not, the method is not difficult, because you know where two graphs intersect, we are going to put them equal to one another or do a simultaneous equation. That's what we did here. But the numbers are huge, so you'll have to concentrate very well when you do a sum like this. Then, people, I add my x squares. I add my x's, because they're both negative. I add them, and it still stays a negative. And then I've got my 1, 2 to 5 there. Now, people, to factorize this is quite difficult. You can try it, but I would actually say use the formula. Because how are you going to get those factors quickly and easily? The formula will be of great help here. The answer in the end for the 2 points where these two graphs intersect, x is 7 over 13 or x is 175 over 13. Now we'll have to go back to the sketch, because we'll have to look at the sketch to see where these two graphs intersect. Can you see they intersect in A and in P? We got 2 values for x there. Now we must choose the correct one. This one is very small. It is positive. This one is quite big. It's also positive. So people, let's have a look. The x value is small there. The x value here will be much bigger. Can you see it? So which one are we going to choose? That one for A, because they asked us for A, we choose 7 over 13. Now we've got A's x coordinate, but we still need the y coordinate. So let's quickly see whether we can get the y coordinate. We take that x is 7 over 13, we substitute it back into one of our equations. You won't choose this one. You will choose that one, because you've already got the y there. So you're going to say negative 5 over 12. I'm going to substitute 7 over 13. I'm going to write it in standard form, because I can write it in standard form, or I can write it in that form. Then I don't have fractions. So that is what I did here. I wrote that in that form because they actually gave it to us. They said, write this equation in this form. So why would you use the fraction one if you can use that one? But most of us will actually only go back to that because of the fact that that is our number one. But our number one can be written in this form because we did it already. So I'm going to substitute in that one because it's also number one, just written in another way, multiplied by 12. Okay, so 5x, instead of x, we're going to write 7 over 13, plus 12y is 11. Then we're going to say 12y is 11, minus that one, which gives me 35 over 13. And then I'll be able to find y. 11 minus that gives me 2 and 9 over 13 minus 11. That is actually the 11. No, I kept the 12y there. I kept the 11 here. I took that one over, so the signs are 100% correct. And then, people, if I do this on my calculator, this is the value of the y coordinate. And what did they ask us? They asked us the point of A where the two graphs intersect. So I must conclude now. The coordinates of A will be, there I wrote the half of it, 7 over 13 and 9 over 13. This was x, and this one is our y. It's a wonderful sum. It's a sum that's going to consume a lot of your time, because all these fractions. But this came from a question paper that I went through. I told you I did 4 question papers, and I chose sums from there. So it's possible to get a question like this. Good luck with your analytical, and if you get fractions and numbers like these, I wish you much more luck. I hope you enjoy your analytical in the exam. People, I thought I'm done with analytical, but while we were having a rest, I thought of something that I did not show you. I'm just going to tell you how to do this sum. They say determine whether or not the circles having equations like that will intersect. Show all calculations. Now people, you take the midpoints and you determine the distance between the two midpoints. Now this is, I quickly did it, I'm just showing you that, the distance between the two midpoints. And then I add the two radiuses, because the radius of the one is 5 and the radius of the other circle is 3. That was the distance between the two midpoints. These are the sum of the radii. Can you see that the distance between the circles are larger than the radii? Therefore, these two circles will not intersect one another. Just quickly, so that you remember, if you get something like that, you will know what to do. Thank you, people. Let's go on to our trigonometry.